So we are told that the Zambian soya market is growing rapidly, and it has recorded some exports where soybeans and other types of beans which provide oil, vegetable protein, and more than any other plants. So the growth of soybeans production and processing is mainly driven by a fast-growing poultry sector. The climate in Zambia is largely favorable for soya production, and the arable land is vast enough to accommodate the future expansion. The growth of the market for soybeans has ranked 20th in 2020 from its 37th ranking. So we've been given the data below and the demand schedule. So at the price of 80 kwacha, the quantity supplied is 100 and quantity demanded is 500. For 90 kwacha, in packs, the quantity supplied is 150 and the quantity demanded is 450. And we go to the other 100, price of 100, 250 and 400. 110, 350 and 350. Then we have 120, we have 450 and we have our 300. So we want to, from this schedule, discuss 5 key important things. Number 1, can you identify the equilibrium price and quantity from this diagram? What is equilibrium price and quantity? Can you now identify the equilibrium price and quantity from that diagram? So we have equilibrium quantity is 350. The equilibrium price is what? 110. You can tell where the figures are the same. Okay. Equilibrium occurs where demand and supply will meet. So the price there we are having is what? 110 and the quantity is 350. So far, is that clear? You can tell from the schedule. So are we clear on the equilibrium? Then now we have a few questions to answer here. Number 1, we're being asked to calculate the equilibrium price and equilibrium quantity. So that one can be seen from here. Equilibrium price and equilibrium quantity. Equilibrium price. We can even use a demand schedule to plot. So we have the figures here. $80, $90, $100, $110, $120. So this one can be the highest figure on the quantities is 500. Then the price is 120. So you can even sketch it if you want. 100, 200, 300, 400, 500. Then here we have 20, 30, 40, we have 20, 40, 60, 80, 100, 120, and 140. So you can sketch it if you want. So price against quantity supplied, so 80 against 100. So 80 against 100, so we're here. Price is there, quantity is there. So price is 80, here we have 100. And we have 90 against 150. So 90 is there, and 150 is there. And we have another coordinate, 110, 250. So we have 110 is somewhere here, 250 somewhere there. Then we have another 110, 350. That's 100, 250, then 110, 350. 110, 350. Somewhere there. Okay. Then 120, 450, 450 somewhere there. Okay, so the supply goes somewhere like that. Then against the 80 against 500. So 80 against 500. 500 is somewhere there. So we put it there. And we have 90 against 450. 90, 450 somewhere there. Then we have 100 against 400. 100 somewhere, 400 somewhere there. Then we have 110 against 350. So 110 against 350. Somewhere there. Then we have 120 against 300. 120 against 300. Somewhere there. So this is how the supply, this is the demand and the supply. They'll meet at 350 and at the price of 110. Okay, just that the drawing is not all that good. But we can tell from this that our equilibrium is what? Price equilibrium is 110 and quantity equilibrium is 350. Okay, then we go to what is the price elasticity of demand over the price range of 90 to 100 and over 110 to 120. All right. So we know that elasticity of demand is what? Percentage change, quantity demanded, what percentage change in what? Price. So this will be Q2 minus Q1 divided by Q1 divided by P2 minus P1 over P1. So we have P1 is what? 90. P1 is 90 and P2 is 100. So meaning Q1 and Q2 at 90. What is our Q? 90 for the system of demand. We are dealing with what? Quantity demanded. So we put 450 there. Then at 100, what is our quantity demanded? 400. So using this formula, elasticity, we're going to say Q2, that is 400 minus what? 450 divided by 450. Everything, we start again. P2 is 100 minus 90 over 90. So let's calculate. What are you getting as elasticity of demand? So the top part is what? Minus 50 over 450. The bottom part is what? 10 over 90. What are we getting? Quickly calculate. What are we getting? So the top part will be 50 divided by 450, which is negative 0.11. Then we have 10 divided by 90. We also have 0.11. When we divide that, our elasticity of demand will therefore be equal to -1. And we know that elasticity ranges as follows. Between 0 and -1, we say it is what? Inelastic. At exactly 1, we say it is unit elastic. And if it's greater than 1, it is elastic. So at this point, we can safely say demand is what? Unit elastic. So this is unit elastic. So this is between 90 and 110. So we've been given another range here, 110 and 120. So price 1, 110, price 2, 120. So let's check price 1, 110, we get 400. 110, we get 340. So 400 to 350. Who wants to try? 400. And here quantity 2, 350. Who wants to try to calculate? How do you find the elasticity? Tasuli, how do you calculate the elasticity? 110 to 120. 110 to 120. And the quantities we have 400 to 450 to 350. But how do we calculate the elasticity?
The change in price
Mm-hmm.
over the change in quantity. So it will be
Change in price over change in quantity. Is this correct?
Oh, it's the other way
Oh,
around.
it's the other way around. Yes.
Okay. So it's changing what? Quantity divided by quantity itself over changing price divided by price.
Price divided by P1, yes.
So Q2, please don't swap these ones. Divided
Okay.
over
Divided by Q1
P2.
over P2 minus P1 divided by P1.
Correct. So what is our Q2?
P2 is 120
Don't swap them again.
minus 400
Divided by 400. Oh,
400 is 120 minus 110 divided by 110.
okay, so what do we have? On top, we're going to have what? Minus 50 by 400. And here we have what? 10 over what? 110.
10 over 110.
So what do we have on top? Divided by 400.
0.125 divided by 0.09.
Okay. What do we get?
1.39.
So what is our comment here?
It's inelastic. Demand is inelastic.
Inelastic, is it correct?
No,
What is the comment? What is the comment?
it's elastic.
Elastic, right? It's elastic, not inelastic, because it's more than one. So it is elastic. Okay. We agree with that. Do we agree with that? It is elastic, correct. So we proceed. Are we together so far? We proceed. We are now told that suppose the consumer's income have increased. As a result, the price, at each price, 20 more bags of soybeans. So now that the consumer's income have increased, as a result, at each price, 20 more packs of soybeans have been bought. Calculate the elasticity of demand over the same ranges in part 2. So what do we have here initially? We have the quantity demanded as 500, 450. So if 20 more bags have increased, what are we going to have here? 520, right? And here what are we going to have? 470. And here what are we going to have? 420. And here what are we going to have? 370. Here, what are we going to have? 320. So we are asked to recalculate the elasticity of demand. So let's try the first area here. Let's try the first area here. 80 to 90, 520 to 470. 80 to 90. Then we have what? 520 to what? That's going 522, 470. Who wants to try to calculate our elasticity of demand there? Who hasn't spoken? Who wants to help us recalculate our elasticity of demand? Mombi. Who wants to help us? Robert.
It's a Q2 minus Q1 divided by Q1.
The same formula, Q2 minus Q1 divided by over
Q1 over P2 minus P1 divided by Q1.
Okay. So what do we have here?
There we have 420 minus 520 divided by 520. All that's divided by 90 minus 80 divided by 80.
Okay. What do we have here on top?
Divide by minus 100 divided by 520. 10 divided by 8.
Okay. What do we get?
It's 0.19 divided by 10 divided by 0.125.
Okay. What do we get?
Minus 0.19 divided by 0.125. Yeah, 1.52 minus.
Okay.
And that is inelastic demand.
Inelastic, you keep missing it. Yeah.
No, I said inelastic.
Yes, it's not inelastic. It's actually elastic. If it's more than one, it's elastic.
But it's a negative.
No, all elasticity of demand is negative. So here when there's a zero here, that's when it becomes inelastic. All right.
Oh, okay. All right. Thank you.
So all the elasticity of demand is negative. But whenever the range is between 0 and -1, here it is elastic. If it is exactly 1, it is unitary. More than 1, it is elastic. All right, so this 1.5 is somewhere there in the elastic area. Are we together?
All right, okay.
You get the concept. Now tell me A, B, C, and D. One is inelastic, which one is unit elastic, and which one is elastic? A is what?
A is elastic.
B?
B is, it's also elastic.
C?
C is inelastic.
And D?
And D is unitary.
Now you get it. Thank you for that. So remember this part here initially, we had calculated it before the increase by 20. We had calculated it and it gave us what? Some other figure. Okay. Gave us some other figure. That is before the 20, our elasticity of demand was -1, it was unitary. But after the 20, it has become elastic. All right. We've calculated the ranges that we calculated at first. Then also we need to calculate the range between what? Between 110 and 120. Somebody else between 110 and 120. So 110 price 1, price 2 is 120. What is our quantity 1? Our quantity 1 after the adjustments, 110, 400. 100, 400. It's no longer 400, it's now 420. So 100, 420, and 110, 370. So 420, 370. 420, 370. So elasticity of demand is what? Same formula. Q2, Q1, Q1, P2, P1, P1. So here we are going to have what? 370 and that's 420 over 420 divided by 120 minus 110 over 110. Are we together? Are we following?
Yes.
Okay. So here we're going to get what? Minus 50 over 420. Here we're going to have what? 10 over 110. So we calculate this one. What are we getting? You can punch it as I go. We just put open brackets, -50 divided by 420, close brackets, divided by 10, open brackets, 10 divided by 110. You get the answer directly, -1.31. So what is our comment here? What is our comment here?
It's elastic.
Demand is elastic. Do we agree with her?
Yes, we do.
Agree with
Yes,
her?
we do. Yes.
Okay. Demand is elastic. That figure is obviously more than 1. So we're using what? Elasticity formula. Okay. Then we go to the second question. Question that follows. Here we are answering to say, suppose elasticity, 20 more packs. So we calculated elasticity of demand for the range of what? The price 90 to 100. Elasticity here we calculated as this one we calculated as negative 1.53. Negative 1.53. Then elasticity of demand between 110 to 120. We just calculated it as negative 1.31. Okay. So there's no one who's been left behind. We can proceed to something else. So we are taught the second part here with the aid of a clearly labeled diagram. Compare your answers in parts 2 and 3 and conclude the elasticity of demand as the curve shifts to the right. Conclude on the elasticity of demand as the curves shift to the right. So when the demand curve shifts to the right, as we've seen in the above questions, the price of elasticity of demand, what is happening? It decreases for the same range. So elasticity of demand, as we calculated, is a percentage change in goods demanded divided by the percentage change in price. So elasticities of demand, initially we had inelastic here before the 20, and the other figure was what? What was the figure? $1.35. So 1.35, it has gone to 1.31. There we had unit elastic 1.0. It has gone to 1.53. So when the demand shifts to the right, price elasticity decreases for the same range. Okay, so the other questions, we'll look at them later on. We can go to another topic. Which is on consumer behavior, consumer theory. So we need to understand the behavior of a consumer using what we call difference curves. Indifference curves give the consumer and how they behave. The properties of an indifference curve: number one, it has an inverse slope. Number two, it is convex. Three, it doesn't touch, also does not crisscross. Number four, the indifference curves are parallel. Now, under consumer behavior, we need to understand that I is given by the price of good X, X plus the price of good Y, Y. The slope is given by the price of good X over the price of Y. We also have what we call the marginal rate of substitution, is given by the same slope formula. And we also have the marginal rate of substitution, Y for X, is given by the inverse formula, which is different but the same. And we're also given our difference in the utils. The first util and also second util is given by the formula lambda. So when the marginal utility is optimum at the budget line here, we need to understand that it occurs when the marginal utility of X over the price of X is equal to the marginal utility of Y over the price of Y. Each of these ones represents a multiplier, which we call the lambda. The lambda simply gives you the impact of an increase in income on satisfaction. Satisfaction is measured in units called the utils. These are a measure of satisfaction. Being a measure of satisfaction, we can simply say difference curves will illustrate the satisfaction. The difference curve 1 offers more utility. Difference curve 2 offers more utility than difference curve 1. Difference curve 3 offers more utility than in difference curve 2. But because of this budget line, they are all constrained at this optimum bundle, which occurs at this point, which we call the optimum bundle. So Mr. Jerry has an income of 100 kwacha. If his income increases by 1 kwacha from 100 kwacha to 101, his utility will increase from 4 utils to the second utils, which are called 4.05. His 100 kwacha, he wants to spend it on 2 goods, good X, which costs 10 kwacha, and good Y, which costs 40 kwacha. Write down the budget line. Obet, what's the formula for the budget line?
It's M, or is it I, is equal to PX plus PY. Price of X plus price of Y.
Okay. So at this point, what do we substitute? What is our M?
Our M is 100.
Our M is 100. Yes.
Our X is 10 quarter. The price of X, PX 10 quarter.
Mhm.
And the price of Y is 40.
Excellent. So here we're going to put 100. The price of X is what? 10. The price of Y is what? 40.
40.
Right. So we're going to sketch this. How does it look like? On the Y and the X, you to cut the Y at what? We divide the intercepts here. 10 into 100 is 10. 40 into 100, 2.5. On the Y-axis, we put 2.5, that's the maximum. On the X, the maximum is 10. This is how we illustrate this budget line. Question 1, write down the budget line and sketch it. Part B, what is the impact of the 1 quarter increase in income? Impact is the Lagrange, which is a difference in the second util and as a first util. So 4.05 minus 4. The difference is 0.05. So a 1 quarter increase in income will result into 0.05 increase in satisfaction. So this is what we have here. Right. Number C, find the slope. The slope is simply given by negative px over py. So this is 10 over 40 negative. We get negative 0.25. This is what we call our slope. Number D, they ask you find the marginal rate of substitution y for x. So we divide the price of y over the price of x. So this is negative 40 over 10 and negative 4. This is how many units of y x can be substituted for y. 4 units. How many units? 4 units of y can be substituted for x. So x makes y 4 times. All right. So for this budget line, how many units of x will we consume at 1 unit of y? So we substitute this in the equation. Where there's y, we put 1. So we're going to have 100 is equal to 10x plus 40 times 1 is 40. And this one goes aside, it's going to subtract from 100, we get a 60. So we divide both sides by 10. The number of units of x will be 6. So if 1 unit of y is consumed, it will be also at 6 units of x. Suppose we went to 8 units of x. How many units of y could we consume? We went to 8 units of x, so here we put 8. And you leave the y there. we're going to have 100 is equal to 80 minus what? Plus 40y. When the 80 goes this side, it will subtract. We have 20 is equal to 40y. When we divide both sides, we're going to get what? 0.5 for the y, or half. So far at this point, any questions? So far at this point, any questions? Are we moving together? Are we moving together? Are there any questions?
So, Mr. Collins, the formula for the marginal rate of substitution, is it only this one? There's no other formula for the marginal rate of substitution.
It's that one. Yes. There are two marginal rate of substitution, x for y or y for x. The one x for y, we start with the price of y over price of x. Then x for y, price of x over price of y. The slope formula is the same as the marginal rate of substitution. X for y, it's the same.
Thank you.
Right. So now the examiner could give you a scenario to say we have following utility functions. Point A and point B. This is A and this is B. Here we have 60. Here we have 40. And here we have 8. At point A, we're told the price of good X is 10 kwacha. And at B, the price of good X is at 15 kwacha. Okay, so we're saying we have the following points. this is 60, this is 40, and this is 80. And we are told that at A, price of good X is 5 kwacha. Then at B, good X, and just say good Y is 10 kwacha. What are the budget lines? So let's go to A. At A, we're told is 5 kwacha, so 5x, but we don't know what the price of good Y is. We're being asked to find the budget line and the income. So we know that at good X, at X, it is cutting the X-axis where at 60. So put 60 there. To find the figure here, we multiply 5 times 60 to get 300. At Y, it is cutting at 40, so we put 40 there. To know why it's cutting the Y, are you able to get me now? Am I clear? The network is fluctuating.
Yes,
Yes.
Okay. I hope it doesn't fluctuate again. All right, so what was I saying? I was saying the case, we have A and B. This was 60, this is 40, and this is 80. And A is here, and B is there. All right, we have utility 1 and utility 2. If the price of good X is 5 kwacha, what is the budget line? So what we just do here is, we know that income is equal to price of X times X, price of Y times Y. So here we're going for 5x. That is cutting the X on the 60. So multiply 5 times 60 to get 300. And it's also cutting the Y on the what? 40. So to get the amount of the Y, we divide the 40 in there, we get 7.5. What is our budget line here? 300 is equal to 5x plus 7.5 Y. Other one, at B, we're told that B price of Y is 10 kwacha. So we know that income is equal to price of X times X and price of Y times Y. So in this case, where there is Y here, we put 10Y, but it's cutting the Y at 8. So we're going to multiply 80 times 10, which is 800. It's cutting the X at the same 60. So to find the intercept there, we divide 800 divided by 60. So when we divide 800 by 60, what do we get?
Mr. Collins, just a minute. How did you get the 7.5?
How do I get 7.5? Somebody?
Divide the 40 into 300.
So he has clarified where the figure is coming from. Is that clear?
Yes.
All right. So with regards to B, here we have what? 80 and we have 60. The price of B at Y, it is 10. So since it's cutting at the B, the Y is cutting at 80, we multiplied what? 80 times 10, which gave us 800. Then to cut at X, it is cutting at 60. So we divide 800 divided by 60, we get 13.3. I rest my case, we end here. Have a good evening. Thank you so much. I'll send you some homework.